Deep at the bottom of the ocean, there are hypersaline lakes that act as perfectly still mass graves. Any creature that swims into these dense brine pools instantly goes into toxic shock and dies, its body perfectly preserved for decades in the black, oxygen-starved water. Looking at these toxic underwater lakes is like looking at Earth 2.7 billion years ago. Long before animals existed, our planet was covered in chemical-rich seas, choked with methane and sulfur, with no breathable air in the atmosphere. Everything we know about how Earth became breathable follows a single biological rule. Life-sustaining oxygen is produced by cyanobacteria and plants through photosynthesis. This requires two ingredients, liquid water and sunlight. By that logic, the further you sink into the crushing darkness of the deep ocean, the less oxygen there has to be. The surface life uses it up, and in the pitch black, there is no sun to create more. In 2013, marine scientist Andrew Sweetman traveled 13,000 feet down into the Clarion-Clipperton Zone of the Pacific Ocean to measure exactly how fast that remaining oxygen was disappearing. He deployed a benthic lander, a specialized machine that traps a specific volume of deep seawater in an isolation chamber. Sensors then track the rate at which local marine life consumes the oxygen trapped inside. But when Sweetman checked the data, the oxygen wasn't dropping. Despite the fish and microbes breathing it in, the oxygen levels inside the sealed chamber were actively increasing. He ran the tests again with different equipment, but the result was identical. Miles beneath the surface, completely isolated from sunlight, something on the ocean floor was actively breathing life into the water. To find the source, Sweetman looked at the only physical objects present in the area, millions of black, potato-shaped rocks called polymetallic nodules that carpet the seafloor. He teamed up with chemist Dr. Franz Geiger to test these stones in a lab. They recreated the exact conditions of the Clarion-Clipperton Zone, pitch black, freezing, and under the intense pressure of the deep Pacific. To determine if microscopic life was responsible for the gas, they soaked the rocks in mercury chloride. This highly toxic disinfectant killed every trace of biological activity, leaving only the sterile stones in salt water. They sealed the disinfected rocks in an airtight container and tracked the sensors. Even without a single living microbe present, the oxygen levels inside the jar began to climb, reaching 3 times the normal concentration. This confirmed the source of the gas was entirely abiotic. These dead stones were somehow generating oxygen gas on their own. Dr. Geiger analyzed the internal structure of the nodules and found they function like a battery. They are built from alternating layers of manganese, which acts as a positive terminal, and iron oxide, which acts as a negative terminal. When the team placed a voltmeter against the surface of a single rock, it registered a charge of 0.95 volts. On the ocean floor, these rocks cluster together by the millions. By touching one another, they act in a series to amplify their power, pushing the total voltage well past 1.23. 1.23 volts is the exact energy threshold required for electrolysis. The nodules produce enough electricity to break the bonds of the surrounding water molecules, splitting H2O into separate hydrogen and oxygen atoms. The bottom of the Pacific is effectively covered in trillions of natural batteries, electrocuting the water to create a constant supply of dark oxygen. This discovery has put scientists in direct conflict with deep-sea mining corporations. The Clarion-Clipperton Zone contains over $16 trillion worth of these nodules, making it one of the most valuable mineral deposits on Earth. Companies like the Metals Company want to harvest these rocks to extract nickel and cobalt for electric vehicle batteries. They frame this as a necessary step for the green energy transition. However, independent research suggests that removing these nodules would collapse the local ecosystem. Thousands of species, from deep-sea crabs to mussels, have evolved to survive specifically on the dark oxygen these rocks provide. If we allow industrial dredging to clear the seafloor, we will permanently disconnect a natural life support system running for millions of years. This abiotic oxygen also changes how we look for life on other planets. We have historically focused on planets near a star, assuming sunlight was the only way to produce oxygen. But if geological batteries can create air in total darkness, life could be developing right now in the frozen, subsurface oceans of moons like Europa. The deep sea provides a working model for how biology can emerge without the sun. Before we allow corporations to bulldoze the seafloor for short-term profit, we must realize we are looking at one of the few places where we can still see how the chemistry of life actually begins.